All right, here we go. Welcome back. We're talking about columns. A couple quick announcements. I'm looking at next week for an exam, right? As it stands now, I would say next Thursday or Friday. Okay, those are kind of the two options, and I got to come up with a way to maybe poll you guys and see what your thoughts are there on what day would be better and at what time. And I am, as probably you are as well, completely 100% wide open. Right, so we could take it in the morning, we could take it in the afternoon, we could take it in the evening. It's up to you. All right, and it's just gonna be the same format as last time. True, false, fill in the blank, things of that nature to start out with, and then two problems. One problem being the slab design, okay, and the other problem being column design, which we'll finish up right here. Both of those things I do not believe are too difficult, but and that kind of sets us up for the next. I mean, we'll be done with concrete after that, and then can finish out with steel. So today will probably be. I think I said this last time, but today will probably be the last lecture on concrete. So let's get started here. The other thing I do have to work out is if you want some FaceTime with me, how we're gonna do that. I mean, I could make myself available certain hours, but then I'm not sure how many people would show up for it and things like that. So stay tuned for how we're going to handle that aspect of it. So what did we do last time? Last time we were talking about column design. We said, oh, hey, look, spirals are way better than ties. You get this type of behavior. You're confining that core. You're holding everything together. Ties help some, but they don't help a lot. If you don't have anything in there, it just crashes out pretty quickly. Okay. And I saw Jaden downstairs a few minutes ago breaking your column. So we'll wait and see how those videos turn out, and you kind of see what the data looks like. Right, or at least what the video looks like. I'm not sure if he recorded data or not. So then we said, all right, let's look at the mechanics. The mechanics are we assume that the steel yields at a strain, or sorry, not the steel yields, that the concrete crushes at a strain of 0.003. That's a uniform strain across the whole thing because it's concentrically loaded. Given those strains, we then can calculate the stresses. The stresses are 0.85 F prime C from the concrete, and then all of our steel yields because it's all going to 0.003, so it goes beyond this 0.002 right here, and so it's in the yield plateau, and so are all of our steel yields. And then given that, we can calculate what those forces are, and then the forces from the concrete and the forces from the steel have to add up to this axial load that's applied here. Okay. And it's a little weird with the up versus down. It's like internal forces versus external is what's happening there. But the idea behind it is you sum all of these things up, and then that's how much load the column can carry. Okay, before failure. And so that's what this whole process did. And what we ended up with was this equation right here. Right, the axial load capacity is the total area steel times the yield stress, plus this 0.85 F prime C, that's the stress in the concrete, times the area of the concrete. This is the gross area of the column, and then you subtract out the area of the steel, okay? And that's really close to the equation that shows up in our, in the ACI code, right? We briefly talked about the effects of bending and what that does. Basically, if you add axial load, or if you add bending to an axially loaded member to a column, it decreases your capacity. The alpha factor is in there and included to account for that accidental eccentricity and the decrease in capacity. And then MN down, and then if you have a beam that you add axial load to, it actually increases its moment capacity because it's just the way that the mechanics work. And by the end of these PM interaction diagrams, and then the way you work them is you plot your demand, and if you're inside the curve, you're okay. If you're outside the curve, you're not okay. Oh. I forgot I had scheduled a call right now. I'll be back. I'm going to post this as 2 videos. All right, I wonder if I can pause this sucker.